All right, can I go ahead and grab everyone's attention? So I think overall we're progressing well through this. There's a couple of small things that I want you to take notes on with these problems, okay? So this is a common issue that I'm seeing throughout, okay? First things first. KJ, eyes up here. I need you to take these notes, okay? First things first. Write your factored form, right? We have it currently in what form? Standard. That's in standard. Before you just write your solutions down, you need to show me the factored form. If you already know that you are struggling to write the factored form, write out the general factored form first. What is the general factored form? A times
x minus 1 times x minus 2.
Remember, by writing the exponential function repeatedly, you've gotten better and better at it, right? The more times you write out the factored form, the better you're going to remember it. So write out that factored form. And then when you look at the graph, first off, what is my a in this factored form? There's nothing in front of x squared, so it's understood to be 1. Then it was x. What was that? What was an x-intercept? 2, comma, 0. So x minus 2. And then the other one was?
X minus 0?
6.
Oh, 0, 6.
Comma 0. So x minus is equal to 0. Remember, I know that you don't have to do this next step because you actually already know the solutions. But for future classes, I need you to write this step out, and I will be assessing this on understanding checks and tests. From the factored form, what do you now need to do? Solve, but how am I going to solve? X is equal to 0. And x minus 6 is equal to 0. That's the whole point of the zero product property, is that either the first factor is 0 or the second factor is 0, right? So x minus 2 is equal to 0, and we have x minus 6 is equal to 0. We good on that one? Okay. And so from there, solve it. And I do want you to notice the roots, the x-intercepts were 2, 0 and 6, 0. But am I including that 0 in these solutions?
Nope.
No. Right? 2, 0 and 6, 0, those were x-intercepts, but those were not part of my solution. My solutions are just x equals 2 and x equals 6. We good on that detail? Yes. Good? We're not going to go all the way over B. Just the main point to remember on B is I can't write factored form yet. Why not? It's not equal to 0. So what do I need to do? Add 7. And so negative 7 plus 0, or negative 7 plus 7 is 0. Now I can do factored form. Right? And we do need to be careful here when you look at those x-intercepts, negative 1, 0 and negative 7, 0. This is why I would recommend writing out that factored form every time. Because what do you get when you subtract a negative? A positive, right? So it's actually supposed to be x plus 1 equals 0 and x plus 7 is equal to 0, right? Writing that factored form out is going to help you remember, hey, I'm subtracting a negative, so I need to add. It's the opposite. Okay? So C, this is where I do want to pick it up as a class, and D as well. First off, we already said equals 0, we're good. What were the roots? 0, comma 0, and
1.25. 0,
comma 0. So how would we write this in factored form? Remember, it's a times x minus r1 times x minus r2.
2 over 3.
Say that one more time.
2 over 3.
2
divided by 3.
2 divided by 3, or 2/3, times
X minus 0.
x minus 0. Do I need to write it as x minus 0?
Yeah.
I could just put x in there, so I'll show it this way, and then x minus 1.25. You can get the fraction version of that, but that's fine as well. So you could also just write this as 2/3 x times x minus 1.25. From there, what are you going to do? Set each what? Remember, this is called what form? Factored form, so we would call each of these a factor, right? From there, you're going to set each factor equal to 0. We good on that detail? Now, someone was freaking out, not someone, a couple people were freaking out because what are we not equal to in D? 0. But can you substitute a 0 in for f of x? Yeah, remember, that's just saying y is 0, which those are x-intercepts, correct? There's a bigger problem with this one. Did anyone see what the bigger problem was when they graphed it? What was the equation again?
Oh, they were both positive.
It's okay to both be positive. What was the equation? X squared?
They were the same.
X squared plus 10x plus 12.
Okay. Can anyone tell exactly what those x-intercepts are?
No,
So what can I do?
that little weird thing you showed us.
That little weird thing. What is that little weird thing she's referring to?
Menu, analyze.
Analyze that graph, okay? So let's analyze that graph.
You knew what I was talking about.
So analyze graph, 0.
I know.
Yeah.
Then we start calling them.
Yeah.
I'm not those things weird.
So I want you to look at these really quickly. Did y'all get that many decimals? You probably just got like 2 or 3, right? Maybe 1 or 2. So I want you to notice, are there more decimals than what you got originally?
Yeah.
Okay? Are these decimals technically repeating or terminating? If there's more decimals afterwards. So these are probably irrational numbers. What do we mean by irrational?
They have no reason.
No. Either the decimal neither terminates, which means it doesn't stop, or it doesn't repeat, which means that those decimals keep going forever and it never has a pattern to it. Well, if that's true, do we know exactly what this number is right now?
Well,
No.
that one would be repeating if we 8.6.
If you go further in that decimal,
No.
it doesn't.
Okay, well.
Yeah. No, that's a good thought. I'm glad you brought that up. So let's go settings, display, let's go float 12. That's going to sound crazy, but there we go. You see how it's not repeating anymore? Yeah. So short term, it did look like it was starting to repeat, but when you look at more decimals, does that repeat?
No.
No. So these are known as irrational roots. So can we actually write the factored form right now? No, because we don't actually know the exact roots. So if we can't write the factored form doesn't work. Remember, we already talked about it earlier. When it was a graph like this, were there any x-intercepts in the first place?
No.
No. Right here we have irrational roots, right? So the only roots that you can actually find using graphing, right? So I want you to notice, it says use factoring to solve each quadratic equation if possible. The only time you can use the factored form is when the roots are rational. So can't. We can only use factored form when the roots are rational. Which I will define this word rational for you in a second, but we can only use factored form when the roots are rational. So we can't write factored form here. This is a note that you want to star and pay attention to. Because this means that we need another form, or another strategy. So a rational number. What do we mean by that?
It's consistent.
Kind of. There's one of two things is happening. As a decimal, the decimal version, either 1 terminates. What do you think I mean by terminates?
Yeah.
It ends. So give me an example of a decimal that ends.
8.5.
8.5, 8.75, 2.1. Those are all decimals that terminate, right? So they either terminate or the decimal repeats.
8.5555.
And that 5 keeps going for forever. Or 0.3 repeating, that's 1/3, right? So it is a rational number if the decimal version either terminates or repeats. But I also want you to look at this word right here, ratio. What's an example of a ratio?
Like 3 to 2.
3 to 2?
1 to 1.
1 to 1? And how can I write ratios?
Dot, dot.
Yeah.
With the dots or 3 to 2. 1 to 1. 1 to 2. 2 to 3. So a rational number can be written as what kind of number?
Fraction.
A fraction. Every decimal, or every number that has a decimal that either terminates or repeats, it is written as a fraction of what are known as integers.
So D supposed to be written as a fraction.
Well, we can't. That's the whole issue, right? Those decimals didn't terminate, they didn't repeat, so they're not rational, so we can't factor it. Or we can't write that factored form. Does that make sense? That's the whole thing, right? And that, so I'm telling you we can only use factored form when the roots are rational, so I wanted to define what we mean by rational. So what form do you think we can use? Remember how we talked about the fact we can always use vertex form? And there's a beauty to vertex form. Make sure you have these notes. I'll continue in a second.
Mr. Again?
Yep.
Can I go after Jay to get that?
Sure. Can I erase this part over here that's over parts of the slide? We just need the definition of rational. So, how much fun does this process look like?
No.
Not fun? It's not terrible, I'll be honest with you. However, it's more work than we have to do. I want you to look at this end product right here. If I subtract 13 from both sides, anybody recognize this form? What is that form? Vertex form.
Okay.
You see how it's x minus h squared plus k? Factored, or it's vertex form. So did I need to go through all of this? No, what could I have done?
Vertex form.
So what do I need to get vertex form?
You get 0.
A,
I need a, what else?
K, H.
K and h, right? Yeah, and I'll say this, factored form you had to have a 0. You don't have to in vertex form. That's part of the beauty of vertex form. So it does help sometimes, but what I want us to recognize is if I'm trying to get vertex form, I just need, well, first off, how am I going to get a, h, and k? I'm going to graph it. There we go. Right? Just like we graphed to get the x-intercepts, we're going to graph this. We're going to graph this in order to get the vertex form. I'm trying to see if there's any other notes I need here. Yep, that's all. So, number 1, complete the square to determine the roots of each equation. Okay, you see this terminology, complete the square? Once you complete the square, that's the algebraic process. What form are we going to get? Because we were just talking about it. Say it again. Vertex form, right? So if you see any language in math that says complete the square, what you're going to get is vertex form. So to make our lives easier, what are we going to do? We're not going to complete square, we're going to what? Graph it to get our vertex. Graph those equations, get your vertex form, and then we'll go from there. So work with your group, graph those equations, get that vertex form, and we'll go from there. Come on, Jelani, stay awake. Come on. There you go, don't put that equal 0.
Okay.
Yep, nope.
Yeah, I got that.
So how are you gonna find that vertex?
It's,
So yeah, just notice, what we have is a minimum there, right? So analyze that graph, find your minimum.
wait,
Go back to it.
It's the same.
how do we know it's a minimum? What do you do?
Well, I mean, is that a high point or a low point? That's the lowest point on the graph, isn't it? That vertex, there's nothing
Oh,
below
yeah,
it, so
we're
that
trying
is
to
the
find
minimum.
vertex. I thought we were trying to find the.
No, yeah, we're trying to find the vertex, right?
So minimum.
Well, we got a lot going on here. So instead of having all these graphs at the same time, what you can do is you can click on these little check boxes. Scroll up, check on those check boxes, and that'll turn those graphs off.
I got 3 common negative.
And then go to analyze the graph.
Okay.
Something
So,
happened.
Okay.
Oh,
It's regular.
multiply.
Then I got a negative.
Is it minus? You're on.
You do minus five.
yeah.
Did you get 3
I
common
was like,
negative?
do you know how I knew this was wrong?
A is 1.
It's not quite a line, it's what we call a cubic, but is it a parabola?
No.
No, right. So how are you gonna find that vertex there?
Square.
Jaden?
Yeah.
So,
And then minus
First it's
1.
right up vertex.
Okay.
and then it's-
Anybody know what our vertex is? Or what's another word for our vertex in this case?
Okay, the next one.
The line of symmetry goes through the vertex, but where do we see the vertex there?
Equals what?
So remember that vertex is that point at the very bottom in this case.
Equals what?
It can be very top, a maximum,
Y equals.
but notice that's called a minimum. It is the lowest point in the graph.
yeah.
So where are we gonna go and find that
You
minimum?
going to the right
And
thing?
did you-
Analyze it.
that one said it doesn't mean it's 0.
He's on November 6th, right?
Vertex.
Yeah.
What did you just call that vertex? It's also a what?
And your birthday
Okay,
was
so-
that period?
It would
Right,
be.
because we're not doing x-intercepts, we're not doing factored form.
Oh, yeah, I think I got another
Oh, you could just put minus instead. I got you.
X
Do we get our
minus-
factored form? Don't forget it's equal to what?
Yeah.
Oh, shoot. You mean vertex form?
So 3 is the H.
Equals 0.
Yep.
So X minus 3 squared
Just hold it. You don't hold it.
plus.
No, hold it.
All right, let's talk about this. I think we're starting to get there. We'll have to wrap this up tomorrow, but I want to point this out. What was the first thing we had to find? The vertex. The vertex can always either be one of two things. What are those one of two things?
Minimum and maximum.
Minimum or a maximum, right? So, hey, by the way, if you have a graph still on this, you don't have to create a whole new graph page. You see how I scrolled up to F2 of x? You see that check mark on the left-hand side? If you click on that check mark, the graph goes away. Right? The x-intercepts are still there, but what was the equation again? X squared
Yeah,
minus 6x plus 4. And so we need to find that vertex, also known as a what in this case? When I go to analyze, what am I looking for? A minimum, right? In this case, it's a minimum. Now I want to point out, if your parabola is concave down, what are you going to have? A maximum, right? A concave down parabola is going to have a maximum. But the process is the same, which, yeah, it's fine. I don't know why mine got anything but 3, but the vertex is 3 comma what?
-5.
-5. Now that I have the vertex, what is my A again?
1.
Oh, and also write your vertex form out, get that practice. So then 1 times x minus 3 squared. Now if I add a negative, that just becomes what?
Positive.
If I'm adding a negative, so that'd be -5. What would I now do to solve that equation? It's already equal to 0. We should recognize this from what we did in the bell ringer.
Plus 5.
Add 5, right? That's a 0. So x minus 3 squared is equal to 5. Now what?
Square.
Remember it's 1, so 1 times anything is just that thing. So take a square root. Can you take the square root of 5? Is that a perfect square? No, this is the beauty of that vertex form. So x minus 3 is equal to what? Positive or negative square root of 5. You can leave it just like that. X is equal to 3 plus or minus the square root of 5. Just leave it just like that. You'll get that irrational number if you get the decimal, so don't make your life harder than it has to be. Sorry I sped through that. We'll spend more time tomorrow practicing that. I wanted to get this up there. So here's your homework. Please be aware of this, right? It looks like a lot. Part 1 is due Friday for sure. Part 2, because we'll finish that on Wednesday. Part 2 will probably be due next Tuesday. But I just wanted you to go ahead and see this, right? This is from lesson 5. This down here is from lesson 6. So take a picture of your homework. Make sure you know what it is. I'll put up your calculators if you got to go to your next class now.
Mr. Kenny,
Yes, sir.
are we turning in the one we had to do?
Here's our homework.
Oh, yeah, I already. Oh, sorry. For some reason I didn't collect yours. That's my bad. Did anybody else? I didn't get their homework. You get put on my desk. Thank you. Sorry, I don't know why I got distracted and forgot to do it. That's Gracie. Miss Shannon, do you feel better about those problems we started yesterday?
Yeah.